Kirkle Math. All right, ladies and gentlemen, we are looking at 9.2 reflections. Our objective is to reflect a figure given a description and write an algebraic expression of the reflection. So here are our notes on our new vocabularies. A reflection is a flip over the line of reflection, which creates a mirror image. Okay, when we flip something over, it's going to end up being backwards or upside down. That is because, like a mirror, if I shine something in a mirror, look at something in a mirror, it's going to be backwards or flipped upside down, depending on how I'm looking at it. Okay. In my example here, my line of reflection, which is a line a figure is being flipped over, in this example with my little winky face here, my line of reflection is my x-axis. Okay. That is my line of reflection. Okay. I know that this is a reflection because my shape has been flipped over. It is no longer facing the same direction. I also know this is a reflection because the distance between the line and the reflection and all of the points on my shape is the same as the distance between my new image and the line of reflection. So if the top of the smiley face is 4 units away from my line of reflection, then the top of smiley face B prime is also 4 units away from the line of reflection, just in the opposite direction. If the corner of this mouth is 2 units away from the line of reflection, then the corner of this mouth is 2 units away from the line of reflection, but in the opposite direction. Okay, all of these points that are on my little shape are going to be the same distance, equal distance away. And that's actually how you reflect something over a line on a coordinate plane, is you just count how far away is this point and then do that on the opposite side. How far away is this point? Do that on the opposite side. Okay? All right. We're basically just going to be using x value or y axes and x axes. Those are going to be our lines of reflections. If I'm writing it algebraically, what happens is when I flip or reflect over the x-axis, my y value changes signs. It becomes the opposite sign of what it is. And the reason for that is because if I take a shape here and I reflect it down here, my x values are still the same, but my y values went from positive to negative. So I'm going to change its sign. Same thing with the y-axis. If I am flipping across my y-axis, and this one's a little easier to see with our image, this point is still in the same spot on y. So I'm not going to change my y value, but I did go from a negative x value to a positive x value. So my x value will change signs. Okay? All right. So then the last thing we have to ask about reflections is, do they preserve congruence and preserve orientation? Remember, congruence or congruent means it's the same size and shape. Does figure B, is this the same size and shape as figure B prime? Yes, they are the same size and shape. But you might be saying, but no, Mrs. Kirkwood, they don't look the same because the winky face in shape B is on the left, but the winky face, the winky eye in shape B prime is on the right. You're right. They have flipped sides, but that is not congruence. That is orientation. So remember, orientation is the way a shape is facing. So in this first image, my shape is facing with the winky eye on the left. But when I flip it over the line, my shape is facing with the winky eye on the right. So down here, I'm going to write, where's my pen? No, it does not, reflections do not preserve orientation. They change the orientation. If I flipped it over the x-axis, it would be upside down. It's not facing the same way. Okay, so now we're going to actually start practicing this. So we have a triangle XYZ. Where are you, pen? There you are. Triangle XYZ, and we're going to graph the image of the triangle after a reflection across the x-axis. So that means my line of reflection is here, and I'm trying to take this triangle and flip it over and up, okay? So I'm going to measure my distance. X is 3 units away from the line of reflection. So X prime needs to also be 3 units away from the line of reflection. Y is 1 unit away. So Y prime needs to be 1 unit away. And then, of course, Z is 5 and Z prime is 5 units. Once you've measured out your points, then you can connect them and you can see how this triangle has flipped up and is now in here in the top quadrant. Okay? Now to do this algebraically, we know that when I reflect over the x-axis, the y value is the one that changes signs. So if I was to do this algebraically, I would take the points of all of my corners. All right, I'm going to write that up. I'm going to take these points and I'm going to apply this. I'll change my color here. I'm going to apply this rule to it. I am going to make my y value the opposite sign. So it is almost like I am multiplying the y's by -1, okay? Multiply by -1. So if I do -3 times -1 makes a +3. It just changes its sign. It goes from negative to positive, okay? So I'm going to rewrite x prime as 1 +3. Y prime becomes +4 +1 instead of negative. And Z prime becomes +6 +5. Okay, and so you can see here that the -3 turned positive, the -1 turned positive, the -5 turned positive. So the only thing I did was change the y value. And then we can double check that that's correct by checking our points. This is +1, +3. Y is at 4, 1, and Z is at 6, 5. Okay, so we're going to try to reflect this one over the y-axis this time. So this time we're going to go across from left to right, and we're still just doing the same thing. I'm going to count, okay? A is 2 boxes away. So I'm going to go 2 boxes in the opposite direction. C is 2 boxes away. So I'm going to go 2 boxes away in the opposite direction. And B is 1, 2, 3, 4, 5, 6 boxes away. So I'm going to go 1, 2, 3, 4, 5, 6 for B prime. Then when I connect my points, you will now see that my triangle is now flipped over the other side. This time, I'm going to be doing -x and +y. So if I write down my values for A, B, and C, I can change the sign of x to get A prime, B prime, and C prime. All right, so to get A prime, I'm just going to change the sign of x. So +2 becomes -2, and the y stays the same. B prime, -6, +2. C prime, -2, +2. And then again, you can check that with your points that we graphed. Now this problem has something a little bit tricky about it. You might notice that the line of symmetry goes through the shape. And what that means is that my shape, the top half of the shape is going to flip down, but the bottom little piece of the shape will flip up. And my shape will actually flip and overlap each other. So my pre-image and my image will be on top of each other, okay? So I can do this by counting, but I figured I'd show you that algebraic way because this way you can kind of do the math and not worry about this weird visualization of them overlapping and then graph your points, okay? So here, because I'm going over the x-axis, my y value is going to change signs. So D prime is going to go to 5, -4, okay? So I'm going to go ahead and go 5, 1, 2, 3, 4, -4. This is D prime. Z prime is going to go 3, -3. So Z, 1, 2, 3, right there. M prime is already at 0, 0. If I change the sign of 0, it's still 0. You can't have a negative 0. So M, because it's on the line of reflection, is also M prime. This point is both M and M prime. It's actually going to rotate and flip, or not rotate, it's going to flip right over this point. And then P prime is going to be 4. I had a negative 1, so now it's positive 1. Okay, so P is going to be up here. I'm then going to just connect my points in the same order that they are in my pre-image. And obviously my shape's a little wonky, but now you can see that right here is where we flipped. This little triangle bit went from down to up, and then this big kind of quadrilateral bit went down. Okay, I know I did it correctly because if I count my squares, 1, 2, 3, 1, 2, 3, they're all the same distance from their pre-image. 1, 2, 3, 4, 1, 2, 3, 4. Okay. Now on this problem, we don't even have to track the points. We can just use our algebraic representations. Okay, we're going to do the y-axis, and we are going to flip over the other way. So I can take t, and I'm going to do the opposite. It's going to be negative x, and then y is going to be the same. So my t prime is going to be negative 2, positive 2. Okay, go ahead and do the rest of those. Pause the video, do the rest of those, and then check your answers with me. And there are your answers. So hopefully you have your dots reflected correctly and your coordinates. Okay. Whoops. So then you can go ahead and do this one right here. Reflect this pentagram across the y-axis and write the algebraic expressions that go with it, and we'll check it in class.